Hello, I'm Lee from Data Harvest. Today we're going to show you our Bluetooth current and voltage sensor working with our EasySense 2 software to induce a voltage, so magnet going through a coil. You can use any coil you want. I tend to use the Hermot's coil here because it's a larger diameter and it's easier for the magnet to go through without hitting the sides, because when it does, obviously it will affect the experiment. Our voltage sensor here, it's a voltage and current sensor, even though we're only going to be using the voltage today. You could actually, for this experiment, use voltage or current. I tend to prefer the voltage. This is 5 volt and 0.1 amp. We also have another different sensor, which is 20 volts and 1 amp. So if you are using higher power source, more cells, then obviously you would use the higher one there as well. These are USB and Bluetooth. USB on the bottom. Bluetooth, just hold the button down for a couple of seconds. It will start to flash. That's now broadcasting Bluetooth. Now the good thing with our EasySense 2 software is it will only pick up Data Harvest Bluetooth devices and will not pick up any other Bluetooth devices broadcasting within the science lab or further afield in the school. Now we've got current that way and voltage that way. It tells you on the top of the label which is which. So we're going to put the black into the black on the voltage. And there you go. So we've now got that on there. So we'll pop that just there. Once the software is open, it won't connect automatically. It will be if you have it plugged in through USB, because there could be multiple Bluetooth devices within the classroom. Now this is when the 6-digit unique number on the front, when you go and click on devices, it will tell you straight away what the sensor is and then those 6 unique digits afterwards. So therefore you shouldn't be connected onto somebody else's by accident. You can see from the screen here, someone else is using Bluetooth within the building already. But I'm going to click on current and voltage, finishing at 086, which is what that one is just there. So it takes a couple of seconds to connect. Now turn off the current, because again, not using that one today, just going to use the voltage. Not just going to click play today. I want to be a little more controlled with this experiment, because it's all going to happen within about 1 second. So I'm going to still run continuously, but I want some parameters. I'm going to log at 1 millisecond. I want it when its value rises above a certain amount. Now, the problem with this, the whole experiment is going to last about 1 second. If we go further down on here, I want to stop login after a duration of 1 second. If I click start, pick the magnet up and drop it through the coil, can I do that within 1 second? It's highly unlikely, or you rush it, or it won't go as smoothly as you want. So I'm going to put a trigger point in. So I'm going to tell it to have a pre-trigger point now of 500 milliseconds, so half a second. Now what that does is let me go and click play, so just check I've got it all right here. So 1 millisecond, value rises above, I didn't put that in. I want 0.05, I want 50 millivolts. So I don't want it to start logging until the voltage goes above 50 millivolts. So just going to save that there as well. It's going to trigger it after half a second and stop after 1 second and collect 1001 readings. So if I now click the play button, you'll see on the software it's waiting for trigger. So what it's doing is going round in circles. So as soon as it goes round in circles, as soon as it goes round after a second deletes and keeps going round and round. So as soon as it goes above 50 millivolts, it remembers 50% of the information beforehand and then continues for a further 50, for then another half a second afterwards. So magnet, remember which way round you drop it to start. So I'm going to drop this way around just about this height. So drop that through. You'll see we've now dropped it through and it's shown on the screen perfectly. But what I'm going to do now is click overlay at the bottom, click the start button again, reverse the pole. You should really measure exactly the distance each time, but it was about yay height. So we're all logging again. Also going to pop that one through there. Now that's a lovely graph on the screen. I'm going to click on voltage on the y-axis because I'm going to tell it min-max, just so we can blow that up. There you go, so you can see that nicely on the screen there as well. Now if I go to tools and go to values, you'll see on the red one down here we were 254 millivolts there, and if we go up to here we were 280. So you can see as it came out at the bottom of the coil that it actually induced a higher voltage. It's the same also on here on the second time, so you can see the green there is 256 millivolts and then there it's 308. Now the misconception with the children here is because this peak is higher than this one, the area here is more than the area here in the first one, which it isn't. So what we're going to do with that is I am going to go to area to prove the area is the same each way. So we're having the top area minus the bottom area, or vice versa, whichever way you wish. And you can see they are within 0.002 area the same, which proves it's exactly the same each way. We have lots of videos on our Secondary Academy, which you can get to through our website, which takes you to our YouTube channel. We have the videos in 3 sections. The first section is how to use the Bluetooth sensors. Second section is how to use the Bluetooth sensors with experiments. And the third section is how to use the EasySense 2 software. That's all at data-harvest.co.uk. And if you'd like more information, please contact us on sales@data-harvest.co.uk. Thank you.